Okay, here's that opening problem that I said I'd make a video for. So we've got these things, there's four people left, we have all these probabilities. I think you already solved and saw that the probability that B would be A is going to be 60%, because 40% that A beats B, so we've got that down. And then what we need to do is need to represent this in a tree diagram. That's really what question 2 is all about. So the whole deal is, let's just start with A and B, okay? Because I think that that is the easy one to start with. So if I have A and I've got B, probability that A wins is 0.4. The probability that B wins is 0.6. And then they have to play either C or D. So the probability that C beats D is right here. That's this 35%, so 0.35. So there's a 35% chance that if A wins, the next opponent's going to be C. That's going to be the same here, where we'll have 0.35, which means that this is 0.65. And I think, if I remember your paper, this is exactly what you already had worked out. Okay? So to figure out who's going to win now, we have to figure out, so this just gets us from there, 35% chance it'll be C, and then the outcome of the match is what we're after. This is going to be a win or a loss, and we're talking about 4A. And then for B, we're going to do the same thing, where we're going to do a win or a loss. So for A, there is a 0.55% chance that they beat A, and a 0.45 chance that they lose. And then here for D, again, this is one of the biggest pains with this whole process in terms of tree diagrams is I didn't plan very well. So if we do win-loss against D, they've got a 47% chance of winning against D, which means they've got a 53% chance of losing against D. Similarly, we can go down here and we can find what B does. If B plays C, their win versus their loss is 42% for a win, which means that it's 58 for a loss. And if they play D, it's 54% for a win. Okay. 0.46 for a loss. Okay. That is a nightmare and it's a mess. Sorry. Now, to figure out who's most likely to win the grand finale, what we have to go through is we are going to deal with the idea of, so the chances that A wins is going to be A intersect C intersect with the win. So that's 0.4. Let me just change my ink color just so we're on this. So this is 0.4, getting it from there, times 0.35 times 0.55. But there's another way that A can win, and that's when A plays D and then beats D. Okay? So for that, we need to add along that trail. So that's 0.4 times 0.65 times 0.47. Okay, so that will be the probability that A wins. Let me just grab my calculator real quick and do that. 0.4 times 0.35 times 0.55 plus 0.4 times 0.65 times 0.47. So overall, the chances of A winning is that 19.9%. Okay. Now, I'll do it for B as well, and then we're going to have to go back and do it for C, which isn't that big of a deal, but that's where this problem is going. Let me just do B, just so we're clear on how this works, and then you can find all of the others, I think. So B wins. Again, that's B plays against C and then beats C, plus B wins the first game, plays against D, and then wins against D. Okay, so B winning, that's 0.65, or 0.6, I'm sorry. 0.6 times 0.35, grabbing those two, times 0.42, plus, it's that same 0.6, times playing against D, it's 0.65, grabbing it here, and then winning against D is 0.54. And again, just plug and chugging our way through that with our calculator. 0.6 times 0.35 times 0.42 plus 0.6 times 0.65 times 0.54, and we'd see that they're about 29.9% chance of winning. Okay, so, and then we can do that same whole process for C and D. I'm not going to write it, I'm just going to do it on my calculator, I guess. So for C to win, the two opportunities are A wins, then C has already won, and then A loses, which is 0.45. I'm grabbing these from here. A wins, they play against C, and then they lose against C. That's those values. And then the other option is B wins, 0.6. C has all, so B wins, they play C, then B loses, so 0.58. And that's going to give me 18.5%. So our C winner and then for D, you have options. We could go through that same exact process again, which is absolutely fine if we wanted to, or we could just add this plus this plus this and subtract that from 100%, and we would have it. Just for grins, I'm going to do on my calculator going through this way. So in order for D to win, we've got A has to win, times D has to be there to play them, times 0.53, which is the chance that A loses, hence D wins, and then 0.6 times 0.65 times probability that B loses is 0.46. And that would give me 31.7. So D is about 31.7%. And then just to check my math while I'm here, I'm just going to grab that, I'm going to add to that probability, and I'm going to add to it this other probability, and then I'm going to add to it this last one, and this should be 1. So it's 1, so we've got it there. I hope that was helpful.